Hello, welcome. It is video flipped classroom number 5 and it is Thursday evening. So welcome. Let's see what we have in store for us today. We introduced show that's last night and we were working along on those, and I'm looking at the ones that I assigned and I'm picking one to work out for your benefit, or 1, 2, or 3 I said. So I can't remember which one you said you were on, so that figures. Let's say that I'll jump down and I'll look at 21, 23, 21 and 23. And that's a basic my plan. I'll give you some strategies as we go for show that's. And this note is to Abby. Abby, we missed you today and heard that you weren't feeling well. And hope that you're feeling much better and are able to get back into the classroom soon. All right. Also, Abby, I have a worksheet that I'll show to you, and you can be working on these problems along with everyone else. So I'll probably do that on part 2, so only you have to view it. So we'll see how long this takes. Which reminds me, I need to set the timer. All righty. Give ourselves 10 minutes from now, and those extra few seconds won't matter much. All right, on number 21, it looks like this. Picking one which I think that you probably haven't got to address at all, or not very much. Cosine theta, cotangent theta, and 1 minus sine theta, and a minus 1 just hanging out here equals cosecant theta. All right, we talked just about a strategy on these. This is mostly for your benefit, Abby. We will always start these problems from the left, and we begin by rewriting the problem, the left side, and then we'll start altering what it's equal until we get to the right side. So all I've done so far is taken the left side and recopied it, and I'm going to show that it equals that. Alright, on this one I found it useful to go ahead and substitute cotangent as cosine and sine. Everything's in cosine and sine. So I just went ahead and I'm going to start here and make a change. So cosecant theta, cotangent, we know, cosine over sine, and 1 minus sine minus 1. So you can see the only alteration took place right there. So cotangent became that. Now I'm going to take that. I took this value and I flipped it and multiplied by it. Of course, I can only do that on this fraction. It can't affect the minus 1 because it's not under the minus 1. So when I take this and flip it up, I got cosine and a cosine up there, which I'll combine in a minute. And when I flip this and put it up here and multiply, you'll see these two expressions are on the same level, the sine and the 1 minus sine. And we've got the minus 1 tagging along just for fun. And now I decided at this point to rename this cosine squared. My space is limited, you can just rewrite it. And I decided to give this the same denominator as this. So, and I just left it in its factored form. So is not 1 this over itself? So I can't remember. I hope this works out. So I have sine theta 1 minus sine minus, now I'm to the 1, and I'm going to call it sine theta 1 minus sine theta over itself. So So far, the only items, the only articles out of our trig travel case that I've actually used is renaming this as sine and cosine, and then dividing a fraction by flipping and multiplying, which is just algebra. And then I decided to add them algebraically by giving this the same denominator. So now I'm going to have this part over this common denominator. Let me make some room up top here. Can you see down low? I think it's visible. It'll be a little bit squished. So this equals cosine squared minus, I'm right here, now this top, sine theta, 1 minus sine theta, all over the common denominator, sine theta 1 minus sine theta. Alright, I'll probably drop you off there. Is that a good dropping off spot? Oh, I guess not. I'll do one more step and then I'll drop you off. On the top here, I'm going to distribute this and you will see something useful happens. So cosine minus, so distributing the sine, I get a sine theta and a positive sine squared theta. Notice the sign out here will cause this sign in here to become positive. So now I have sine 1 minus sine. And right here I see cosine and sine, cosine squared and sine squared. So whenever I see sine squared and cosine squared, I can replace them with a 1. So cosine squared plus cosine squared is 1. So now I have 1 minus sine theta over sine times 1 minus sine. So I'll let you finish and see if you can get it all the way to the end. Alright, that's my discussion on 21. So 23 is, actually 23 isn't too bad. Maybe I should look at, let's look at. How about 17? I hope you haven't all got that one. I don't know why I can't remember, but I thought when you told me, oh, I'll remember that. Wrong. Okay. Let's look at number 17. And that is show that cosecant x minus sine x equals cosine x cotan x. Alright. What I noticed here is somewhere along the line I might have some fraction work here and here. I'm going to have to combine them under a like denominator somewhere because this is only one term and because there's no plus or minus here, and this is two terms. So those two are going to have to combine to one. So I noticed that. So I think what I did is, of course, I write down what's on the left, cosecant minus sine, and I changed that to sine and cosine. And I gave that a like denominator, so I had to multiply this by sine x over sine x in order to do that, and it creates a lovely 1 minus sine squared x over the common sine x. But we know 1 minus sine squared x, and this is where we become one term, is cosine squared x over sine x. And now let's see if you can break that apart and sort of patch one cosine with the sine and leave the other cosine and see if you can get it to equal what it should from there. Alright, so I don't want to make a lot of of work tonight. There is a visionary meeting, and if I want you to feel free to go to that, and in that case you don't have to even do these two problems. But if you're at home tonight, go ahead and wrestle those two that I started almost to the end and see if you can complete them. So I will talk to you tomorrow. I'm going to put a part 2 on here where I actually shine those pink problems up for Abby to see so she can begin working on them as well. All right? Very good. So short and sweet. Over and out. Bye.